Okay, what is a possible reading if you use this graduated cylinder? Okay, now, you have one?
15.
15, okay. And who was your partner? All right, what did they think? You thought that was good or not?
Yeah.
Okay, and who had another one? Who had another one? I'm not going to say yes or no, but who had another? What'd you have, Hayden?
35.
35? Okay. And who had another one? And your partner thought that was good, right? You thought that was good?
I got something different.
What'd you have?
I was. This is probably.
Okay. What did you have, Matthew?
25.
25? And who was your partner?
Yeah.
Okay. What did you have? 20? Okay. Now, so far, I'm going to be nice to you. So far, no one has given me a correct reading. Does somebody else want to try it?
69.
21.00.
Say it again.
21.00.
21.00. Who was your partner? Thomas, what did you think about that?
I agree with it.
Okay, everybody? All right, now so far, I still have not heard any correct measurements. Sorry.
I got it.
Yes?
It's like 35 milliliters.
Okay, I like the fact you put a unit with your number. I do like that. I still have not heard a correct measurement. All right, now let's transfer it. So somehow, what we talked about yesterday didn't transfer to the real thing. So that's why we're doing this.
Oh, I know.
All right, significant figures are all the numbers that you're sure about because you have lines for them, right? And then you have to guess how many. One, where you don't have lines. So take a look at that graduated cylinder. Do you have a line for tens place? Like 10, 20, 30, 40?
Yeah.
Okay, you don't have to guess tens, do you? Do you have lines for the ones place?
Yes.
Yeah.
Then you do not have to guess the ones. Do you have lines for tens place? Then that's when you start. That's when you have a guess. Isn't that right? So what's a typical reading here? 28.5, yeah. 32.1, yeah. If you went past tens place, you can't. You're telling me, if you go to hundreds place, you're telling me you have lines for tens place. You didn't. All right, let's try another one. Everybody get this? Can you see that pretty well? Yeah, there you go. All right, write down. Write down a typical reading using this graduated cylinder. You have to write it down, Sean. Write it down. Are you doing it already? Wow, fast. All right, show your neighbor. Show your neighbor. See, now you know a little bit more. Okay, you should talk to Taylor. Okay. Who has not talked to anybody? Hey, turn around. Talk to Rachel. I know, talk to Rachel. All right. Is there anybody who has not talked to anybody? Okay, now, raise your hand if you said, I know what you're doing now. I'll give you one. All right, Ben, volunteer.
9.50.
9.50. I'm not going to say yes or no. And that's a milliliters, isn't it?
Yeah.
Okay, anybody else? Yes,
7.63.
milliliters, right? Anybody else? You want to try it, Thomas?
How much? Put 10.
You what?
Put 10.
16?
No, 10.
Oh, 10. Okay, yes?
I'll put 9.51 milliliters.
Okay, what do you think?
7.52 milliliters.
One more time.
7.52.
All right, let's take a look. Do you have lines for tens place here?
Yeah.
Well, that's the whole graduated cylinder, isn't it? So, but I don't have 10, 20, 30, do I? But do you have lines for the ones place? So I'm certain about the ones. Do you have lines for tens place?
Yeah.
Then I'm certain about that. And you have to guess how many? You always guess one pass, so you run out of lines, right? So if you went to hundredths place, what'd you say, 10? You can't say 10, but you say 10 point what? 0, 0. You understand that? And please don't ask your math teacher that. They'll say, silly, there's no difference between 10 and 10.00 because they don't use measured numbers. You get it? But when you use this graduate cylinder, you have to go to hundredths place, don't you? All right, you understand that? So we're going to do a lab based on this chapter, and you're going to pick up all kinds of instruments, and you're going to have to learn how to read them. All right, let's go on. So now, what if you aren't there? What if you aren't there to use the instrument? You said, well, what? Oh, yeah, magnify. Thank you. Thanks for helping me. There you go. Is that what you said? Okay, yeah. Now, anyway, let's go back here. Every scientist and every engineer on the planet, they know about significant digits. And now you do. But what if you're not there to see what kind of graduate cylinder they use? And the only thing I told you yesterday I didn't like about this handout sheet, it didn't have units after, so you can just make up your own units, like grams here and centimeters here and I don't know, whatever. So, but anyway, if you're not there, how are you supposed to tell someone else what your instrument looked like? And here it is, watch. They have these rules that every engineer and scientist know to tell whether or not a number is a significant digit or not. A significant figure, same thing, sig fig. Rule number 1, it's a fast review, okay? Rule number 1, if you are in a measured number, and you're not a 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, you're in. You're in the sig fig club, aren't you? So watch. I'm in. In. Pretty easy for rule number 1, right? Rule number 2, if you are a 0 and you are trapped between two significant digits, like the cream and Oreo cookie, right? Then you're in. Now these are not trapped. No. There's a trap. So rule number 2, they're not trapped. There's only one part of the cookie. Not trapped. Trapped. Okay, not trapped. And, a lot of them trapped. Everybody okay with rule number 2? Rule number 3. This is the only one you have to really pay attention to. The first 2 are easy, aren't they? Easy. Trailing zeros. Trailing what? Don't say decimal. Don't say it. Trailing what?
Sig fig.
Sig fig. If you trail a sig fig, are you in the club? No, not automatically. If you trail a sig fig and there's a decimal somewhere, then you're in. Okay, so let's try it. Are there any trailing zeros here? Do you see any zeros that come after the 2? No. Well, then what about these? No, there's no rule. No. So how many total sig figs does this guy have? And that means you had a terrible ruler. If this was centimeters, here's what your ruler looked like. 0 and, here's all the way to 0.1. 0 and 0.1. And you say, 0.02. You had to guess the 2, didn't you? If you only have one sig fig, that instrument's not very good. It's not good. Look at this one. How many sig figs here? What about this trailing 0? Does it come after the 2? Is there a decimal? Then you're in. So how many total sig figs? 2. And that means it's a little more expensive instrument. How about these? Oh, already all 3 of those are marked. How about this trailing 0 here? As it comes after the 1, doesn't it? Do you see a decimal?
Yes.
Then you're in. How about these trailing zeros? Are they in? No, there's no decimal. There's only one sig fig. Now again, the scientists, they don't want to be tricky. So how would a scientist write this in scientific notation? Like that. And then you can easy to see how many sig figs. How many sig figs are there? You only look at this part. 1. Good instrument or not? Expensive instrument or not? No. Not a very good one. Look at the next one. How many sig figs? Are these trailing zeros in? They trail the set. They come after the 5. Are they in? Yes. Ooh, a little expensive instrument, right? And again, I don't want to fool you. So how would I write this in scientific notation? 5.000 times 10 to the third. Now you know I had how many sig figs? I really did have 4, didn't I? That was an expensive instrument. Very expensive. How about these trailing zeros? They come after the 1. Are they in? Yeah, there's a decimal. 1, 2, 3, 4, 5, 6. 6 sig figs. How about this one? Why are you looking at these zeros? Why? What rule says these zeros are in? Not 1, not 2, not 3. I think I'm done. How about this trailing 0? It comes after the 2. Is there a decimal? You're in. And we're done here, right? Is that right? That's what we did yesterday. We also, I'm not going to, you can watch the video if you want to watch the other part. I also went around the room and asked people to write this in scientific notation with the correct number of sig figs. Now, if you knew there were only 3 here, then how would you write this in scientific notation? How do you write 8,040 in scientific notation showing 3 sig figs? Yes?
8.04 times 10 to the third.
If you can do that, you are way above most students taking chemistry, okay? How about this one? How many sig figs does that have? It has 3, doesn't it? And so how do I write that in scientific notation? 3.00, see that has 3 sig figs, doesn't it? Times 10 to the, remember how to do scientific notation? Yes? Okay. All right, so I'm not going to do all those again. If you do want to watch the video yesterday, you can see all these, or you want to come after class, you want to take a picture of that, you can. But I don't want to spend much time on that. Now, let's do one more thing here. What if these rules only applied to measured numbers? What about a counted number? Like 3 pens. Is that a measured number or is that a counting number?
Counting.
A counting number, like they use in math, is considered to be the perfect number. And so how many sig figs does it have? An infinite. You guys ever done the infinity symbol?
Yeah.
Okay, it has an infinite number of sig figs, okay? It's perfect. It's perfect. What's this now? Where do sig figs come from?
Measurement.
From the measurement tool, right? The measurement tool. Like some tools are not so good. Some tools are better. All right, next. And the last thing, all measured numbers have 3 things in common. What are they?
Numbers.
A number,
Error.
a unit,
Error.
and error. Very, very good. Everybody got that? Okay, we said this in class. And then the last question on this page, when is 3 centimeters not necessarily 3 centimeters? Raise your hand if you think you know. Yes, Taylor.
It's measured.
Yes, yes, yes. Because if I gave you a more expensive instrument, it might be 2.991. Isn't that right? Okay. All right, everybody ready? Now, does everybody have a calculator? If you get your calculator out, I'm going to go around the room. We're going to sign. I'll tell you what, I think I'll sign a pair of you problem. So see you guys, you first 2, you're a partner, and you'll be a partner, and then you'll be a partner, and then you get partner, 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 and partner. Okay? All right, I don't think I've run out. I want to show you on the next page, and some of you are going to like this because you like numbers, and some of you are going to say, oh no, something else I have to learn. Okay. Guess what happens when you start doing calculations with numbers that have error? You don't want to tell a lie. You don't want to have a lie. So some people call, you know what statistics are? That's a group, that's when they study mathematics and probability and the likelihood of something. Anyway, we use statistics for a lot of things, but when they found out, scientists, engineers, you're going to use measured numbers. You're going to have a set of rules you don't have in math class. Here we go again. When you start doing calculations with numbers in math class, that's pretty easy. You just write down the answer, don't you? But what we're going to do here is you guys are going to do number 1, 2, 3. You're doing number 4, 5, 6, 7. Now, what will happen is I'll do one for you. I'll do number 9, okay? Well, no, I don't have that. Okay, I can't do that. I don't have a calculator. Wait, maybe I have the answer here. Wait a minute, let me look. No. No, okay, I'll do it. Hey, let me look up here. I'm going to show you what happens. If you were to multiply this with a calculator, let's say it's this times this times this, the calculator will say this. Now, matter of fact, that's a lie too, because your calculator is so dumb, it doesn't know what a centimeter times a centimeter times a centimeter is. Now you do, because you know what x times x times x is. What's x times x times x? X to the third. And if you thought, what, isn't it x cubed? Yeah, okay. That's x cubed, isn't it? So what's a centimeter times a centimeter times a centimeter? Centimeter cubed, also known as a cubic centimeter. Okay, now, so your calculator says this, and if you're in math class, guess what? You better write that down. You better write that number down in the answer blank, or the math teacher, the mean old math teacher will say, that's wrong. That's wrong. But if you write this down in science, you're a liar. And you say, what are you talking about? Oh, you're a liar. Because guess what? This is called volume, and you're saying that you took this number and this one, and you can tell me that the volume is this number here? I'll tell you why you're a liar. Because look how many sig figs this has. How many? 6. But what numbers did you use to come up with that? How many sig figs here? How many? Uh-oh. 3? How about here? 3? How about here?
2.
Did you know, you're telling me you can give me the calculation with 6 sig figs, and yet one of your measurements only had how many? That's your weak link, isn't it? You cannot write down any more than what?
2.
It says here, when multiplying and dividing, round to the least number of significant figures. Again, you'll never hear this in math class. You get it? Okay, so let's try it. How do I round this to 2 sig figs? Now watch now. Here's 1, and here's 2. Now, this is important. When you round, you don't chop. Now, see if you can answer this question. If I want to round to 2 sig figs, do I ever look at the third sig fig? Ever?
No. No.
Yes.
Now, raise your hand, be honest with me. How many of you have some teacher in your life had taught you how to round a number? All right. Now, either they didn't do it right or they taught you wrong. When you run around to 2 figures, 2 sig figs like this, do you ever look at the third one? You have to. And if that next one is 5 or higher, that 8's going up, isn't it? The number underneath my finger, and how many things do I look past? Only 1. I only look at 1. Let me show you. I'll show you something I think has happened in your past. What if I told you to round this number off? What if I told you to round it off to the nearest whole number? Okay, one figure. Okay, round off to the nearest whole number. If you want to round that off, it means is the 2 going to stay there, or is it going to go up to 3? How many numbers? If you want to round the nearest whole number, do you ever look at tens place? Ever? You have to. And you know what? I'm not big enough. So how are you going to round this to? You're going to round to what? 2. I know a lot of you don't like that, because here's what you think you do. That 9 makes that a 10. That makes that a 10. That makes that a 10. That makes that a 5. That makes that a 3. There is no such thing as that. If you are The Price is Right and you could win a car, if you just tell me if that number is closer to 2 or closer to 3, you win the car. Is that what you're going to say? It's closer to 3? You lose. So if you thought, if I round to the nearest whole number and you thought I look all the way back here, no, I don't. If you're going to round the nearest whole number, you get to look at one more number, don't you? And that's not big enough. And I guarantee you that number is closer to 2 than it is 3. by a little bit, isn't it? So let's watch. I want to round this to 2 sig figs, right? 1, 2. Do I look at the third sig fig or not? I have to. Watch now. Is it big enough? Oh, man, that thing's big. So now we're at what? 1, 9. Now, watch. Watch now. You're not really going to sit there and tell me that 188,784 rounds to 19? What? What? No. But what do you write? Now, how many sig figs does that have right there? I did not put a decimal. And I did. I rounded to 2 sig figs, and I have the right number, don't I? 190,000. All right. Yes or no? So if you're doing a problem down here where you, and by the way, this is a misprint right here. You might as well get rid of that right there. That's a misprint. If you're doing a multiplication or a division problem, look what it says. When multiplying or dividing, round your answer to the least number of sig figs. Okay, so those of you who are doing one of those problems, here's what we're going to do, right? Like Hayden, you guys, you're going to write the actual number the calculator gave you over here. Then you're going to look up, you're going to say, I'm going to use this rounding rule, and you're going to put it here with the unit. Now, the statisticians that told them that you don't want to be a liar, that's the rule you have to do for that. Look at this rule here. What about when you add or subtract measured numbers with significant figures, right? When you add or subtract, I wish it was the same rule, but it's not. What does it say? When you add or subtract, what do? Round your answer to the what? Least number of decimal players. No? Decimal places. Now, by the way, be careful. Your math teacher wants to tell you that decimal places only mean the places to the right of the decimal. That's not true. Guess what your number system is based on? It's called the decimal number system. Every number is in the decimal system. So let's watch this here. Ready? This plus that. The calculator says that. Now, the rule says you have to round it to the least number of decimal places. All right, what's this one go to? Hundredths place. What's this one go to? You guys, aren't you in 10th grade? What is this one at? 10th place. And what's this one? Thousandths place. What's the least number of decimal places? No, you're going the wrong way. The least number, 10th place, isn't it? So now, if you're going to round this number to 10th place, let's take a look at that. Is that 5 going to stay or not? If you want to round to 10th place, do you ever look at hundredths place? Ever, ever. I'm looking at you. If you want to round to 10th place, do you ever look at hundredths?
Yeah.
You have to. Oh, not big enough. Sorry, you're not big enough. Now, if I'm around to 10th place, do I ever look at thousandths place? No. I only look at 1. And so what am I going to write down here? I'm going to write what? What's the answer going to be? 255.5. And again, the calculator is so stupid, it doesn't know what a milliliter plus a milliliter plus a milliliter is. What do you think? What's an apple plus an apple plus an apple?
3 apples.
Well, no. What are blah, 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 blah apples plus blah, blah, blah apples plus blah, blah, blah apples?
I don't know.
It's, okay.
Bunch of
What? Yeah, that's right. And the unit's going to be what? Apples. It's going to be apples. What's the unit going to be here? Just milliliters, right? This was centimeters times centimeters times centimeters. That's different, wasn't it? All right, does everybody know what they're doing? Okay, so what you're going to do is you and your partner are going to write down what the calculator says. You're going to look at the rule, and you're going to tell me what the answer is here, okay? Let's go. All right, I'll give you 2 minutes. I'll give you 2 minutes to do that.
Was that the answer? All right. Yeah, it's to the part. Yeah, sure. No, it's 6.7. And now what do we do with the rule? We do this.
Now you can each do it and then talk to your partner and say, here's what I got on the calculator, here's what I think you should round it to. All right,
So it's big enough.
Thomas is Taylor. Taylor is Thomas. There you go. This is where you talk. This is where you talk to your partner. All right, you guys are done?
This is done.
All right, are you ready? Anybody need more time? You need more time? Okay, which one are you doing? 10? Oh, 7. This is actually liters. It's not liters cubed, so liters divided by liters, no units. You aren't going to have any units. All right, now some of these are harder than others, so I'm okay if you make a mistake. But what I want you to do is, Hayden and you guys and Luke, be loud so everybody can hear your answer. I'm going to write down what you told me, and then you tell me what I'm, as a scientist, what I can write down. So what did the calculator tell me?
3.33045.
Okay, and but now you can't write that down or you're a liar, because this has 1, 2, 3, 4, 5, 6 sig figs, but that only had 3 and that had 4. How do you get 6? So what am I around to? What's the rule say? It says here when multiplying divided, what do you do? Round to the what?
Least number.
What is the least number? How many sig figs?
3.
How many here? What's the least number? 3? So round to 3, ready? Okay, there's my 3 sig figs, right? Now if you want to round to 3, do you ever, Luke, do you ever look at the next one? Ever? Ever? Wait, Luke. Look, if you want to round to 3 sig figs, do you ever look at the 4th one? Ever? Ever? You have to. You have to. And if it's 5 or higher, that 3 is going up, isn't it? What do you think? Oh, no, you're not too high. So what are you going to put here? Give me a final answer, Luke. Uh-oh, you left off the units.
Oh, 3.33.
What? See, the calculator's so dumb.
3.33 meters.
What is it?
Meters. Square.
Ah. You know what they're measuring? Meters is distance. Guess what square meters is? Area. They're measuring area. All right. Everybody got number 1. Hey, look at me. What number 1? What you got? If you had that on the test, you'd get that right, wouldn't you? All right, let's do B. Number 2. Tell me what the calculator said first.
24.642.
8, 5, 7.
8.
Okay. Again, if you're in math class, that's what you write down, isn't it? But if you write down in the science, you're a liar.
And
All right.
for the other one, we got 25 meters. 25.
Wait, what's your rule?
Go. Since it's above 5, it rounds up.
Wait, what are you going to round to?
25.
How do you know that?
Because the 6 is above 5.
Wait, how do you know to round this number? Why don't you round this one? Why don't you round this one? How do you know to round this one? Charlotte, you start talking. All right, hold it. Listen. The question is, how does he know to round the 4? Say it real loud. No? Read this. Hey, everybody, look, we're losing it. Wait a minute. You're doing great. You're doing great. But if you don't listen to what they say, if you don't listen, you're not going to learn anything. So right now they're having a little trouble figuring out, how do I know to round the 4? So what's it say? Round to the what? Least number. How many sig figs are in this one? How many?
4.
Wait. Okay, no, wait. If you can't tell me how many sig figs, we're going to have trouble. 4. All right, how many here?
2.
What's the least number? 2. That's how I knew that it was the second number that was going to be rounded. See that? Now, when I went around the 2 sig figs, do I ever look at the third sig fig? Ever? What do you think? Hey, wait a minute. Wait, I'm losing you, okay? I'm losing. I try to make a joke out of it a little bit, but the joke's to have you make it to remember it a long time. If you run around to 2 sig figs, do you ever look at the third one?
Yeah.
You have to. And I only look at one. I only look at one more. And guess what's underneath my finger? Oh man, I'm big enough. So that 6 is big enough to turn that 4 into a 5. Now here's another trick you had. The calculator is so dumb, it doesn't know what a square meter divided by a meter is, but you do. You know why? Because your math teacher taught you this. Uh-oh. What is x squared over x? X. What's meter squared over meter? Meter. All right. Now, can I tell you something? If you're not learning something, if you didn't learn something from theirs, you didn't learn something from theirs, then I'm wasting time. All right, you guys ready? All right. Now, they have a new problem because this is an addition problem. Tell me what you got.
53.
Oh, the calculus at 53?
121.
Okay. And so now what are you going to do?
Round it down.
Well, you can't round down. Either a number stays as it is or it goes up. Hey, everybody stop. Stop. Okay. What is the rule you're supposed to use? All right. What's the rule for adding and subtracting? What, the least number or what? Okay, so now, ready? Taylor, how many decimal places did this one go to? Just say hundreds place. How about this one? Tens place. And what about this one? The ones place. What's the least number? The ones place. Okay, now, do you see where the ones place is? The 3 is in the ones place, isn't it? If you ever went around to the ones place, do you ever look at tens place? You have to. Ready? Thomas, is this big enough? No. So I keep it at 53, don't I? So did you put 53?
Yeah.
Now, what is a milliliter plus a milliliter plus a milliliter? That's it. Now, if you've been listening to the first 3, you should already have everything done. But we're going to do it again because we're going to see everybody from now on should get them right. You heard their mistakes. You heard their mistakes. You heard their mistakes. So, a little pressure on you guys. You should not make a mistake. I'm ready. Give me this one. Okay, everybody be real quiet about here. Okay, now, what are you going to do here? Why? What's your rule? So, least number of decimal places, right? So tell me, how many decimal places did that number go to? Hundreds? This one? Tenths? So what are you going to round to? What place are you going to round to? Hundredths place or tenths place? Tenths. Okay, now, everybody see this? Is the 5 in the tenths place? Isn't the 5 in the tenths place? I don't want to teach you elementary math. It's a 5 in the tenths place. Now, that either 5 is going to stay there or it's going to go up by 1. You get that? And what do you think? When you went around the tenths place, do you ever look at hundredths place? You have to. It was big enough, wasn't it? So what's your final answer? 26 point what? Yes, and what's a gram minus a gram? Gram, okay. What do you think? Good job? Good job? All right, a little pressure. You should not make a mistake. And here we go. Go. What do you get? What's the calculator say for number 5? 6.72. Okay. All right, now, what are you going to do now? What are you going to round to? And what's your rule? How about that?
The rule is to round to the least number of figures.
Yes. Did you notice in multiplying and dividing, you actually count sig figs, but when you're adding, subtracting, you don't count sig figs, do you? You count decimal places. All right, go ahead. So how many sig figs here? How many? How many? How many? Okay, thank you. There's no way, there's no rule that says that's significant. Okay, 2, right? How about here? How about here? Yes. What's the least number?
2.
Now, if you want to round to 2 sig figs, do you ever look at the third one?
Yeah,
You have to. Is that big enough? No, not big enough. What's your final answer?
6.7 centimeters to the third.
Ah, nice. And centimeters to the third is also known as centimeters cubed, and that's also known as a cubic centimeter.
Oh,
Cubic centimeter. Sorry, when it freezes, I gotta unfreeze it. There you go. Now, a little more pressure. You really shouldn't miss it after you hear all these. Tell me what the calculator says for 6.
3.351 centimeters.
Now, the calculator didn't say that, but it didn't have the centimeters, I bet. Okay, now, what's your rule for rounding? What do you think, Gabe? What's your rule for rounding?
Get around, it's like over 5.
Wait a minute, tell me the rule. Round to what? What's the rule?
Round to the 10.
What?
100, round to the 100.
Is that what it says? Round to hundreds every time? What's it say? Round to what?
The least number of decimals.
Okay, so how many decimal places does this guy have? That's hundredths place, right? Hundredths place? How about this one?
2.
Hundredths. What about this one?
You got 3.
That's thousands place, isn't it? So what's the least number?
2.
Oh, tenths. Wait, what's that again? Hundredths place, right? Hundredths?
Yeah.
Okay. Oh, are we done?
yeah, we're.
Oh. All right, sorry. All right, thank you very much.